Okay, so the very first section of the book is about sets and numbers, and it kind of lays out every different number that we're going to talk about this year and whatnot, and just giving us kind of the basis for what we're doing. So we're going to cover what are the different sets and how do we represent them. Okay. First thing we got to know is what is a set. Well, a set is a collection of items called elements. Okay. So we have a collection of items. You could have a set of different pairs of shoes, pairs of flip-flops. You could have a set of people. You could have a set of animals. You can have a set of forks or different silverware, whatever. Any item. And each individual item is called an element. Okay, so not only do we have sets, we need to have elements. Now, under sets, there are two other words that we talk about. We have subsets, which are basically just smaller sets. So we have our entire set, and then we can pick different ones. So like, out of the entire set of students at Mayfield East, we have the subset, or the smaller set, of freshmen. So those freshmen belong to the original set, but they're just a smaller group out of it. Okay? So we have the freshmen. Another subset might be the sophomores. Another subset might be the people who play basketball. Another subset might be the people who are in band. Whatever. Smaller groups out of the original one. Okay, we also have something called the empty set. The empty set is a set with no elements. Okay. We write the symbol for empty set looks like that. Okay? That means empty set. It means that there's nothing there. That would be the empty set. Okay. For us, we care about sets of numbers. And what we have something called the real numbers. That's every number you can think of. If you draw a number line, every number on your number line is part of the real numbers. Okay, but we break them up into smaller subsets. So we have different subsets of the real numbers. Okay? The smallest subset is n. The natural numbers. And the natural numbers are used for counting, so they're also called the counting numbers. 1, 2, 3, ... Those ellipses mean that it goes on forever. We start counting at 1, we don't stop at 10. You did when you were little, you don't anymore. Okay? That is the smallest of the subsets of real numbers. After that, we go and we get each subset gets more elements, gets a little bit bigger each time. The next one are the whole numbers. The whole numbers are 0 plus the one that's inside, right? Anytime you draw a picture like this, anytime a box is fully inside of another box like this, see how natural is fully inside whole? Well, that means that the natural numbers are included in the whole numbers. So really, yes, we add 0, but what we mean is that now we have all of those different numbers, okay? So that's kind of how that works. I'm not going to write those every time, but at least now you kind of know that, okay, we include the ones that were already there. Okay, getting bigger, we add more numbers. We add the negative numbers. Okay, the negative numbers get the letter Z. It's a fancy Z, it's got the extra line, same with the N and the W. We call them the integers. Okay? So adding in the integers, we are adding in numbers like -1, -2, -3. So exciting, the negatives. People didn't actually believe in the negatives. The negatives were not really talked about as numbers until about the 1700s. Before that, people called them absurd and didn't really think they would work. Okay? We learned about them pretty early. You guys covered them in like 7th grade. But they've only been around for like 300 years. After are the integers? We go to the rational numbers. Of course, they are not an R, they are a Q. Why are they a Q? Because rational numbers are any numbers that can be written in quotient form. Q for quotient, meaning divide. So like 1/2, 1/3, 2/3. Any number that can be written as one number over another number. That also means we can include numbers like 0.9 repeating, 0.24 repeating. Anything repeating, any fraction or repeating decimal or terminating decimal. Terminating being like 0.7 and stops, boring, who cares? Okay? Those are the rational numbers. Set of rational numbers. Now we have 4 subsets of the real numbers. We also have a set in the real numbers called the irrational numbers. Okay? The irrational numbers are numbers that some of them you've probably already heard of. One example would be pi. We don't give anything special for pi. It doesn't fit as a rational number because it never ends. So it is an irrational number. That's how we talk about the irrational numbers. Okay, so pi. E, the square root of 3, the square root of 2, numbers that cannot be written as fractions. Since they are not able to be written as fractions, they don't belong in the other group. They're kind of separate. They also don't get a cool letter. By the way, up here at the top, the real numbers, we call them R. Okay? Those of you following along at home, your book has an awesome little chart of this too, okay? Your book has a great chart of all this information. The book puts it, I just pulled it up, you probably can't see it very well, but it's on page number 6. Great thing in your book, okay? Let's get that out of there. Okay, so now task for you. Oh shoot. Questions for you. Got some numbers to order and classify. Here's the first example. I want you to put them in order and write them from greatest to smallest. Or wait, let me try this again. From least to greatest. Okay? Now as you're looking at those, it's a little bit tricky to do that because what you're looking at are numbers written in different forms. We have square roots. We have things that are decimals, we have things that are fractions, we even have a repeating decimal. The easiest thing to do first is to change everything to a decimal. Change everything into a decimal and then you'll be able to compare things a little bit easier. Okay? For example, 3 times the square root of 2 as a decimal is 4.24. I'm approximating, but it'll work for us. Square root of 7 as a decimal is 2.65. 4 3/5 as a decimal is 4.6. Different than 4.6 repeating. Okay? So to order these, here's what we're going to do. Our smallest one is the square root of 7. That's 2.65. Okay? This would be the smallest one. Okay, now looking at this, we have 4.24, a 4.6, and a 4.6 repeating. We want this one next. 4.6 is a little bit less than 4.6 repeating. And then last but not least, we have our 5.125. Once we write them as a decimal, it's super easy to write them in order. Okay? So that's not all it says. We've ordered them. But now we need to classify. Square root of 7, that is an irrational number. I'm just going to abbreviate it with an I. Irrational. Also irrational is the 3 times the square root of 2, which we rounded to be 4.24. We actually write this the way we want it. It's going to be 3 times the square root of 2. Okay? It's also irrational. They don't get anything else. They're real numbers, yeah. But they don't belong into any of the other subsets. 4.6, which is 4 3/5. Okay, so we probably want to put these the way they should be. Okay, there's 4 3/5. 4 3/5 is a rational number, which is a Q, and it is a real number. That's it. 4.6 repeating, rational number, real number. 5.125, rational number, real number. Okay, I'm going to give you 2 more to do. Pause me, and you give it a try. Your first one is the square root of 5, pi over 2, negative square root of 3, 1.3 repeating, and negative 1 1/3. Okay, your last one is negative 2, 4 1/3, 8.1. Okay. 3 times the square root of 3, and the square root of 26. Okay, so a couple different ones for you to try. Pause me and you try those. Okay, so check them. How'd you do? Negative 3, negative 1 1/3, negative square root of 3, negative 1 1/3, pi over 2, 1.3 repeating, and the square root of 5. And they're all part of the real numbers, but negative square root of 3, pi over 2, and the square root of 5 are all irrational. Anytime you see pi, it will be irrational. Okay? And the last one, negative 2, 4 1/3, square root of 26, 3 times the square root of 3, and 8.1. Right here, the square root of 26 and 3 times the square root of 3. It's important that you change them to decimals. Those are very, very close. Okay, so you gotta change them to decimals and check, and make sure you put them in the right order. Negative 2 is crazy. It's a natural number, which means it's also a whole number, which means it's also an integer, which means it's also a rational number, which is also a real number. It's in 5 sets or subsets. Okay, 4 1/3 is a rational and a real. Square root of 26 and 3 times the square root of 3 are both irrational and then, of course, real. And then we have 8.1, which is rational and real. Okay, so these are the different sets of numbers that we're talking about. Hopefully you got all these right. I really, really hope so.